Right. Good evening. Actually, today we are going to start our new lesson, which is programming one, will be a challenging one. So, right. So let's begin the new lesson. And lesson name is programming, right? Programming. Just write programming with Scratch. Programming with Scratch. That is the lesson name. And this is the chapter number 3 in your school syllabus. When you open the chapter in your school book, it is chapter number 3. This is it. Chapter 1, chapter 2, and chapter 3. Programming. This one. Right, okay. So now we are going to learn that chapter and would be really interesting one. But before we begin, actually, you should know some basic principles of programming. And actually that is there in grade 8 and grade 7. So can you please let me know how many of you have learned programming in grade 7 and 8? Who are the people learn programming in 7 and 8? Yes, grade 7, grade 8. Rasindu, have you learned? Deomi?
Excuse me, sir. I have.
Okay, Hiruka. Anyone else? Anyone else? Okay, I got one message again. Who's this? Yes, Litun. Okay, good. Anyone else? It seems no. Okay, then anyway, since there are some newcomers, since there are no newcomers and some people have not learned this in the previous grades, so let me just explain the basics, right? So before we begin, just learn about the basics. Okay, simply programming means instructing the computer hardware to perform instructing computer hardware and software to perform some task as expected by the programmer. That is called programming. Instructing the computer hardware and software to do something. Instructing the computer hardware and software to do something or perform some task as expected by the programmer is called
So should we write that?
Yes, you are right that, because so why I'm giving this, because I think there are some beginners, that's why I'm giving, right? So those who have done programming, I know they are okay with this, but others can write, right? Those who have completed or done programming, no need to write because you know this. Okay, what is a program? What is a program? It's a set of instructions, set of related instructions. You call program. What is software? Now I'm asking the person from the person that who have done that. People who have done that, can you tell me? So what is software? What is program? Litum, what is software? Okay, Hiruka, what is software? Hiruka, what is software? Okay, now you are silent. I don't know. Right, okay, software. Instruction to computer, so software compromise entire set of programs, procedures, routines associated. Okay, have you copied this? Have you copied or typed? Right. So let's give a simple definition. Software is a set again more programs related data structures and documentation. Because software. One or more programs related data structures and documentation. For an example, you can see MS Word in this interface. Then we'll main interface again on MS Word. Right? Okay. Good. Right, let's so your definition is correct. So let me make this more simple, which you all can understand, right? It's basically instruct the computer what to do. Set of programs, procedures, routines associating the operations of computer system. Yes, programs, procedures, and not only that, right? Not only that, the associated data structures and the documentation also comes under programming, right? Program and under software. Why? So you can see this is software. MS Word is a software, but it is not just instructions or associated procedures and programs, not just that. So when you go on top of these some buttons, you can see most of the buttons, you can see a small tool tip. Can you see? මේ එකක් උඩට ගියාම මේ උඩට ගියාම පොඩි tool tip එකක් පේනව නේද? Here it say text effects. පොඩි tool tip එකක් කියන්නේ උඩට ගියාම පොඩි message එකක් එනවා. Clear all formatting. Line and paragraph spacing. Normal view. When you go on top of that. Saint close. Saint save. Likewise, those tooltip texts, those are actually also belongs to programs. This is coming under internal documentation. There's something called external documentation. There's something called external documentation means basically with the software there's a help or guidance comes. That is called external documentation. With the software arrangement, codes, comments, and all these are coming. That is called internal documentation, tooltips and all. And related data structures. Software should work with data, and that data is also belongs to the software. So data structures are also belongs to the software. That is also part of software. So it's programs, procedures, related data structures, and documentation you can call software, right? Okay. The programming is like, okay, program a set of related instructions. Software is more meaningful. And now tell me, so what is first generation programming language? What is that? First generation programming languages. Those are called machine languages. Can anyone explain the meaning of machine language? What is a machine language? Can anyone explain the meaning of machine language? Okay, I expect you all to talk. Come on, guys. Right. Can anyone tell me how to turn on a bulb? Bulb එකක් on කරන්නේ කොහොමද පුතේ? How to turn on a bulb? No one knows. Come on. How to turn on a bulb in a room, Hiruka?
From the switch.
From the switch. You have to provide power through the switch, right? By turning on the switch, by giving power, by giving voltage, by giving current. Okay, presence of electricity is represented using 1. Absence of electricity is represented using 0. So the language is binary. It's ones and zeros only. Everything should be represented using ones and zeros. That means numbers, instructions, graphics, audio, video, represented using the binaries. This is called this concept is called machine language. Then that is called machine language. Okay, so can you tell me how to give instruction to a washing machine and how to give instruction to a blender and how to give instruction to a bulb? Is it same or different?
Different, sir.
Different. It's different. So machine language is machine dependent. Machine to machine, giving instruction is different. Machine language is machine dependent. Everything represented using this presence and absence of the electricity, binaries, and it is machine dependent. Right, okay. So can you save things using electricity? Can you save something using electricity? Current එකෙන් මොන හරි save කරලා තියාගන්න පුළුවන්ද? Current එක පාවිච්චි කරලා. Can you save something? What do you think?
Can, sir.
How?
Are
Can, sir.
using it on different appliances?
Can you save it? Can you keep it? Okay, when power is not there, then current එක පාවිච්චි කරලා මොන හරි save කරලා තියන්න පුළුවන්ද? Current එක නැති වෙලාවටත් ඒක තියෙන විදියට. Can be. Power is not there, it should be there.
Can, sir.
How?
Sir, from a generator.
Okay. නෑ generator current මොකුත්ම නැතිකොට මම කියන්නේ current එක නැතිකොටත් ඒක තියෙන්න ඕන.
Sir, rechargeable batteries.
ඒත් current එක දීලානේ. එහෙමත් නැතුව තියෙන්න ඕන. current එක නොදී ඒක තියාගන්න පුළුවන්. Can be.
Solar panels.
So there's a mechanism to do that, right? That is called magnetic storage, and so this can be done. So because you need to store ones and zeros, you have to do this. So in optical storage, this is done by burning, right? CD burning. So basically it is done by burning the CD. Burning the CD means it's not like burning like this, right? It's not burning like this. So the burning happens, you can see aluminium, platinum, or there's a layer, aluminium, platinum, or gold layer. This layer can be, right, how data stored. So let's say, okay, here you can see. This is how you store data in a CD by burning. මොකද current එකෙන් data මතක තියාගන්න බෑ. කියන current එක පාවිච්චි කරලා පුච්චනවා. This CD එක තියෙන aluminium layer එක, there's an aluminium layer in this CD. You can see the burn places, no? පිච්චුන තැන් පේනව නේද මේකේ? These burn places are called pits. Pits. These burn marks are called pits. Burn වෙච්ච තැන් melt වෙලා තියෙන්නේ. Melt වෙලා යටට ගිහිල්ලා තියෙන්නේ. So that represent, right? That represent, yes?
Sir, when we delete it.
You can't delete from CDs. Unless it is rewritable, you can't delete. CDs, it's permanent, right? CDs, it's permanently there. You can't delete it. So here you can see these burn places are called pits. This is how it remember one. එක එක මතක තියාගන්න මෙහෙම පුච්චලා. පුච්චපු නැති තැන තමයි බිඳුව. How to burn? Burn වෙන්නේත් මෙහෙමයි. When you get current, there's a laser bulb. That laser bulb will turn on, and turning on here you can see the laser bulb is turned on, and this laser bulb is pointing to the CD, and this layer is melted, and that is how burning happens. Right? You can just further search how CD stores data. Actually this level, this is not there for grade 9, but I'm just showing. You can see by burning the places it stores. When you read the CD, it uses reflection of light to read the CD here. Reflection of light. when it hit a burn place, burn වෙච්ච තැනක hit වුණොත් reflection එක වෙනස්. burn වුණ නැති තැනක hit වුණොත් reflection එක තව විදියක්. It uses this to read the CD. Okay, this is how it happens inside the CD, right? CD එක ඇතුලේ වෙන්නේ. එතකොට current එකෙන් දේවල් මතක තියාගන්න බැරි හින්දා තමයි they use this action. Basically, this is called burning CDs and DVDs. By doing that only, it represents data in the CD and DVD. Understood?
Yes, sir.
Right.
Yes, sir.
Then what happened in the hard disk? How hard disk store data? It uses magnetic particles, something like this. It uses magnetism. අර NS පැත්තට හැරිලා තියෙනවා 1, SN පැත්තට හැරිලා තියෙනවා 0. This head is magnetizing these particles, and you can see this is inside hard disk. This is the head. It magnetizes this hard disk, and then by it stores these ones and zeros. So this
Sir,
is
what is the function of the hard disk?
hard disk is storing data, no? Hard disk is used to store data. I think you know that. Assume that in your computer you have hard disk, C drive, D drive, everything. The operating system is stored in the hard disk. Files are stored in the hard disk. Folders are stored in the hard disk. How storing happen? By using this magnetism, these ones and zeros.
Excuse me, sir.
Yes, Kirushan.
Sir, can we see the laser in the CD DVD drive? You said there is a laser that makes the pit.
Yeah. It's a laser bulb. But now don't think like now you should remove the laser, and some students are thinking like that. They think that laser bulb is powerful enough to cut even glasses. No, not like that, right? So it cannot be used to cut glasses. So that is not that much strong, right? It's strong, but don't look at the laser bulb directly, because it will put your pits and lands in your eye then, right? Don't turn on the bulb and look at that. මොකද ඔය laser beam එක පත්තු වෙනකොට pit and lands ඊට පස්සේ හිටින්න වගේ ඇහි. So don't look at that. So don't look at direct.
Sir, excuse me, sir.
Right, okay. Yes.
Sir, are the functions of the RAM and the hard drive same?
Now the functions of the RAM different thing. It uses flip-flops and leaky capacitors. So I think it's advanced for you. I can explain, but it will be a bit advanced. It uses leaky capacitors and flip-flop circuits, logic circuits. So you will learn that in A levels, advanced levels, right? So not here, right? But those are not same, right? Magnetic disk, hard disk, floppy disk use same thing. CD, DVD use same thing. CD, DVD, same family. Hard disk, floppy disk, jazz disk, zip disk, same family. Magnetic family. Others are optical family. Pen drives, memory card, those are electronic family. Those are using solid state memories, solid state storages. That is different family. And RAM uses different way of storage. Anyway, all are using these ones and zeros. You have to remember that all are using that ones and zeros. So in initial stages, මුල් කාලේ programming ලියද්දී හැම එකම ලියන්න ඕන මෙහෙම using ones and zeros. See how difficult the programming is. To write a number, you know it's very difficult. Writing 10 in binary, you have to divide, it is 1010. Writing 20 in binary, you have to divide and get, it is 10100. Writing 65 in binary, divide and write, it is 10000001. So likewise, you can convert numbers. That can be done. Writing letter A. A is represented using ASCII 65. And that can be done using again the same. It is 10000001. So likewise, everything represented in binary in first generation. That is first generation language. You had to write codes in binaries. So this is actually done using switches. Switch on, off signals. This is done. So I'll show you one thing. Okay, can you see this? Can you see this? Can you see my screen?
Sir. Yes, sir.
Yes. So here you can see ones and zeros are there. Let's assume ones are used to turn on bulb. I'm going to turn on the bulb using red color. Ones are used to turn on the bulbs. One තියෙන තැන්වල මම red දානවා. Red color bulbs. Here also red color bulbs. Sorry. Red color bulbs. Red color bulbs. Red color bulbs. Okay. And here also red color bulbs. Red color bulbs. And here a red color bulb, here also a red color bulb. So what is this? What is this? Yes? What can you see in the screen now?
Ayanna.
It's Sinhala Ayanna. So this is what happened in the monitor. This is what happened in the monitor. So monitor use pixels, and pixels are colored using ones and zeros, right? And that way it displays letters and art, even drawing, pictures, so movies, right? So movie can be break down to this binary. Okay, let me open a movie. Okay, this I'm going to this one. Let's use this one, and I'm going to open a movie. Okay, this one. Let's open this. Okay, you can see. This is a movie. What is this? What is this? දැන් ඔයාලට පේන්නේ movie එකක්ද picture එකක්ද?
Picture.
Then තව picture එකක්. Another picture, another picture, another picture, another picture, another picture, another one, another one. This is actually a set of pictures. Another one, another one, another picture, another one. It's not a movie, no? It's set of pictures. It is set of pictures. But it is played in a sequence where we will understand this is like some action, but it is not actually. It's just set of pictures. Let me take a picture now. I'm taking picture of this picture. Now what I'm going to do is I'm going to open this picture. Now I'm going to open this picture. Where's my picture that I have taken? Okay, seems date modified and seems this one. I'm going to open the picture using Photoshop. I'm going to open that picture using Photoshop now. Okay, now you think this as a picture. දැන් ඔයගොල්ලෝ හිතනවා මේක picture එකක් කියලා. හොඳයි. මම දැන් කරන්නේ මේ picture එක open කරනවා. Open කරලා බලනවා picture එකක්ද මේ තියෙන්නේ කියලා. මුලින් ඔයගොල්ලෝ දැක්ක movie එකක්. Movie එක නැවැත්තුවම ඔයගොල්ලෝ දැක්ක picture එකක්. Movie නෙවෙයිනේ තිබ්බ එතන pictures. Pictures ගොඩාක් play වෙන හින්දා තමයි movie විදියට දැක්කේ. But now I'm going to zoom the picture. Zoom the picture. Zoom the picture. Zoom, 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 zoom it. What can you see now? Is it a picture or set of squares?
Cells.
Yeah, sir.
Yes, set of squares. Let me right click in one cell and I'm going to copy colors hex code. This is single cell or single square. Single square is a number, but this is hexadecimal number. You can see, let's copy one from here. This is a hexadecimal number. But this hexadecimal number you can represent using binary. 0, 1, 0, 0. B means 1, 0, 1, 1. 1 means 0, 0, 0, 1. F means 1, 1, 1, 1. 2 means 0, 0, 1, 0. And 0 means 0, 0, 0, 0. Ultimately, it's a binary. Everything in the computer is actually a binary. But what we see as a result of these binaries is maybe picture, is a sound, or is a video, is a graphic, is a number, something like that. But anyway, actually the true story is those are binaries, right? Don't think much. So I just wanted to tell you everything in the computer is binary, that's all. So if you didn't understand anything, remember the last statement, that is everything in the computer is binary. So remembering that is enough. If you didn't understand anything, remember the last statement, everything in the computer, everything inside the computer is represented using binaries, ones and zeros. But different status, on and off, north and south, high voltage, zero voltage, pith and land, different status, right? It's always not 1 and 0, two different status. Okay, so now the first generation. Yes.
So how many computer number systems are there, sir?
So basically in computers, it uses only binaries. Number systems. So hexadecimal, octal and all.
Yes, sir.
So you are learning hexadecimal, octal and decimal. As well as binary, all 4 number systems, binary, octal, hexa and decimal, those 4 number systems. We are using decimal, computers are using binaries. But to short that binaries, we are using octals and hexas to short the binaries. We are using octals and hexas. Okay, now you know about the first generation language. So, and first generation language fully focused on binaries. Binaries ගැන විතරයි පළවෙනි generation එකේ කට්ටිය හිතුවේ. Is it easy or difficult to think everything in binary? Is it easy or difficult?
Difficult.
It's difficult. For machines, is it easy or
It's
difficult?
Easy.
Easy. මොකද machine මතක තියාගන්න ඕන state දෙකක් විතරනේ, pith and land විතරයි. නැත්නම් north and south විතරයි. එහෙම නැත්නම් high voltage, low voltage විතරයි. Only 2 things. Machines මතක තියාගන්න ඕන දෙකයි. හැබැයි අපිට, for us, we have numbers, instructions, graphics, audios, videos, animations, songs, music, voice, noise, right? Many things. Data, Word files, Excel files, PDF files, VLC media player files, MP4 files, GIF files, right? We have to remember all these things. But for machines, ones and zeros, easy. Power button එකෙත් තියෙන 1 and 0 නේ නේද? දැකලා ඇතිනේ ඔයගොල්ලෝ. Power button එකෙත් computer එක මතක තියාගෙන ඉන්නේ දෙකයි. 0 and then it has 1. 0 and 1 only. නේද? ඔච්චරයි power button එකේ තියෙන්නේ. So computer remember only 2 things, 1 and 0. But for us, we have to remember everything. So machine languages, so easy for computer, so better write down, but difficult for us. Because machine need to remember only 2 things, but for us, need to remember everything. Everything means converting everything we have to do. That is difficult. So therefore, we have the scientist or the computer scientist, they have introduced something called second generation programming language.
Excuse me, sir.
Yes.
Sir, so the games we play, are they made with this binary number?
Anything in the computer is binary, right? But we will not see that binary world. That is the thing. We will not see that binary world because it is hidden from us. Because there are various representations. අපි දකින්නේ movies, characters, games, application. But computer එක ඇතුළට යන්නේ ඕවා binaries විදිහට විතරයි. ones and zeros විදිහට විතරයි. Circuit වල යන්නේ ones and zeros විදිහට. Hard disk එකේ floppy වල, CD වල, DVD වල, pen drive වල තියෙන්නේ binaries විදිහට. So it uses that mechanism because ඊට
So
වැඩි.
what is assembly language?
Yeah, that is second generation language. So let me explain, right? Second generation language is called assembly language. That is basically it assembles binary groups to set of words. It assembles binary groups to set of words. For an example, if you have something like this, you read this as sometimes add, not exactly right, but I'm just giving the example, add register 13 and register 3. Just something like this. So this is add. This is register 13. This is register 3. But still you need hardware knowledge. Still hardware dependent or machine dependent. Still hardware dependent or machine dependent. Need a translator, translate these codes to machine language. Translator name, assembler. That is the translator name. So machines cannot understand this directly because it is symbolic language or this phrase-based language. So it is required to have assembler to translate this to machine understandable language. But easier to programmers than binaries, than machine language. Easier to program in than machine languages. That is second generation. Okay, we learn about first generation, the second generation as well. And the next is third generation. Third generation programming language. So those are called high level languages. High level languages. Human readable languages needs languages. Those are need to be translated to the mesh assembly and machine languages. Two types of translators use. So one is called compiler and the second one is called interpreter. Compiler translate all at once. Interpreter translates line by line. So this is not machine dependent. These languages were not machine dependent. Machine to machine. So then Arakenan Kalin languages, the previous languages, if you code to one machine, you have to recode to the second machine too, because it's machine dependent. You have to code again for the third machine. That is headache. But these high level languages, once you code and compiled and interpreted, so you can run this in any type of machine with this environment, with its environment. So it is not much machine dependent. So the languages that we are talking, the Pascal, Python, Java, C, C++, COBOL, Fortran, all these are high-level languages. There are more, the 4th generation, but we are not going to learn much about these. We will learn in maybe O levels or A levels. We can learn this further. O levels we can learn, right? 4th generation. More human readable. So more human readable languages. And 5th generation, it is AI or artificial intelligence supporting languages, supporting logic languages. AI supporting logic languages were used in the 5th generation. So this is about the evaluation of programming languages. Okay, now we learn like 3rd generation to upwards, but you should know the history because still computers use machine language, right? Still computer cannot use any other language. Computers still use machine language, but only thing that we do is we write codes in high level languages and then translate to the machine language gradually, because this is easy for us. Translators will look after converting these languages to the machine language. Okay, quickly write this, finish this.